All right, let's take a look at analyzing a galvanic cell. Galvanic cell means it is spontaneous, which means we know already that our E cell will be a positive number. So that's our gut check already, is that it has to be something positive because it is a galvanic cell. Okay, so we got a lot going on here. So I'm going to analyze this first with oxidation states. Here I see I have a +3. Here is a +2. So that's a good sign. That is being reduced. We know that anox are red cat. So that is reduction. So that's our cathode we already have. And we'll write all this out here. Then we have our hydrogen, which is +1. So there's 4 there. And so this is -4, which means it's -2 each. This one is 0. So we got a 0 here. So our oxidation is going to be the nitrogen. Now, the first step is we got to break it into half reactions. So let's start with our cathode, which is being reduced, which is our iron from a +3 to a +2. So I'm going to write it out. And that's all we need, irons, but we do need charges. Now there's 4 of them. So in order for this 3+ to be reduced, we do have to add some electrons. Now this can be simplified, right? So iron 3+ plus an electron gives me iron 2+. Okay, so let's type that in. Okay, so there's our cathode, reduction. Anode's a little trickier, right? We got a lot going on. We got into, it's got to be balanced, H4 plus 4OH minus going to into plus 4H2O. We need all this to balance, right? We can't balance the N2 with just N2H4. We need more hydrogens. Now we'll see that we got -4 on this side. So we got to add 4 electrons to this side to make them both -4. Got a charge balance. So I can plug that in. Okay, there we go. Now the next step is to find what our cell voltage is. Now remember, E cell equals cathode minus anode. And these are all reduction potentials. We're going to stick with the reduction potentials, even though our oxidation will show up backwards in the reduction potential graph. We still use that reduction potential when we're writing these in, because it's technically the reduction of the cathode minus the reduction of the anode. So let's find them in our data tab. Okay, so here's our iron. Now make sure you get the right one. I'm doing this one here where I'm only gaining 1 electron, so 0.77. So E cell equals, that's my cathode, minus and here's my other one. Now notice it's backwards, but that's because it's listed as a reduction, and we're still going to use this number as is. So minus a negative 1.16. And there's where that gut check of, is it going to be positive, will help us out. And so we have positive 0.77 minus a negative 1.16, which gives us a positive 1.93 volts. Okay, there we go. Now I put a 1 in here. I tend to do it with electrons and nothing else. ALEKS doesn't like that, so, but still correct. So a lot of steps to this, making sure you're going through each one carefully, balanced reactions. Am I keeping the reduction potential and putting it in the right spot? Which one's a cathode, which one's, I don't know. So a lot to digest. This pretty much wraps up everything we learned today.